Okay, so we continue from this slide. This is basically the location of the Suruga ranges of Chichalina section. So okay, so then what is about the tectonic history of the Indian plate? Tectonic history of the Indian plate from collision to splitting and from the evolution. Firstly, the Indian plate is the part of the Super Gondwana plate, and this is our this Chichalina section, which is situated in the northwest region of the Indian plate. And what 50 million they are the part of supercontinent, but at the Jurassic and the Cretaceous time they are starting splitting from the Gondwana plain because of the various rifting, and then they are still continue to the northwest anti-clockwise rotation at 7 centimeter per year at the Eocene Paleocene time, and they are collide firstly towards western collision and then towards northern collision of the Indian plate with the Eurasian plate. This is our the when they collide. So this is the our tectonic map of Pakistan. Firstly collide northern, so there is various thrust fault are built, and this is the western tectonic which the Shaman transform fault. So we have two tectonics, one from the Eurasian plate collision and other from the other from the Afghan block collision. So you can also see it from the 3D perspective of the western collision, and this is the northern collision. This is basically the northern collision. You can see it. Various thrust faulting are present, but our study is in between the MBT and SRT, and this is the Suruga ranges. This is basically cross-sectional area of the northern tectonics from the MFT to the Karakoram batholith, but our study area is present in the and this thrusting Indus suture zone of the trans-Indus ranges. First of all, what is the stratigraphy and field outcrop of the Chichalina section? So basically, Chichalina section exposes from the Jurassic to Pliocene rocks of the limestone, carbonate, sandstone, and clastic, and the shale. This is the stratigraphic and structural analysis of the Chichalina section. This is the Jurassic strata, which you can see it. Jurassic, Cretaceous, Eocene. This is the context, various context present in the Chichalina section. This is the Google imaginary, whereas this picture are located. This is the Paleocene or Eocene collision or Eocene contact in the Chichalina section. Field observation of the Lockhart limestone in the Suruga ranges of Chichalina section. So basically in Chichalina section the Lockhart limestone are nodular. Why they are nodular? Because firstly they are thickly bedded of the shale and sandstone of the shale and the limestone, but due to the compression, due to the compressional forces, they are become a nodular. Shale is overlapping around the nodular limestone because they the limestone are reduces the stresses, but shale is not accommodate the stresses. So that's why shale are overlapping, but the limestone are nodular. This is the basically field outcrop of the Lockhart limestone, in which you can see in first two images. This is the interbedded nodular limestone with the shale. This is the basically nodular limestone, and the C and D and EF is the contact of the Lockhart limestone with the Paleocene Hangu lower and the upper Patala Paleocene with also with the Namal Eocene, and this is the Cretaceous strata of the Lemshual formation. What material I use in my undergraduate study for the Lockhart limestone petrographic analysis. First is the we go to the field and collect the sample of the 32 rock sample at 1 meter interval. 1 meter interval because of the exposed strata is not well developed, but we try and at 1 meter each the limestone is taken because we mostly focus on the thin section analysis. So only the natural limestone we kept and study at the at the National Center of Excellence in Geology. Before this, we can create a thin section plates of 32 and study one by one. So firstly, we study the microfacies of the Lockhart limestone in Cicciolina section. For this, we can use this Basilina and Busellini chart and Dunham classification for the paleo environment analysis and paleoclimatic reconstruction. So we have different like pyritization, microfacies, dolomitization. We have different biostratigraphy, algae, millionate we can found in this thin section plates. So total nine microfacies we can identify in this Lockhart limestone, desiccate LBF pegstone. So it is LBF and it is pegstone, so it's inner rim because of the larger benthic foraminifera. Desiccate pegstone, it gives the restricted lagoon inner rim because of the desiccate is the algae species, and dolomitized LBF pegstone is the inner to middle because we have LBF, we have the bioclast. So bioclast means the inner very storm influence, and the LBF is the very calm environment, so middle rim. LBF pegstone is also the inner to middle because of the larger benthic forum, which are mostly restricted to the inner and middle rim. LBF wakestone, which is middle rim because it's wakestone, very calm environment, so it's a mid rim. Melodid is specific restrict to the lagoon fishes. Mudstone is very low energy, so it's lagoonal fishy. And the pyritized mudstone is lagoon, but this pyritized means it's the anoxia, means it's the deeper lagoonal part in which the different organism release sulfur or different which react with the lagoonal water to form the iron sulfide, and pyritization is occur. So basically this is the detailed stratigraphy of each sample and give the different environmental presentation, like for example is Cl2, it gives us the LBF pegstone, so it means that it is middle rim, and the Cl19 it gives the desiccate pegstone, so it gives the lagoon fishes. So by interpreting we can also reconstruct the sea level, so it rise and fall along this Tethyan 66 million year in the Lockhart limestone. So then we go to the biostratigraphic analysis of the Lockhart limestone to reconstruct the age. So for the age, this is the in our 32 sample we found this index fossil. So mainly in the Paleocene we can focus the miscellaneous species and Ranicotalia species and desiccate fishes and Lockhart fishes. So basically, so we found these 3 to 4 species, and this due to this Lockhart species, the Lockhart limestone name given to this Lockhart is because of the Lockhart species. So different species gives is present in our thin section, which give the absolute age of the like 66 million 56 or to 46 million year of Tethyan age to the Lockhart limestone. So this is the basically different sample of the Lockhart limestone in which different fossil are present of the range and all are line SPZ shallow benthic zone of the 3 and 4, which represent the Tethyan Paleocene age assigned to the Lockhart limestone. Then in the last we can also find the diagenetic fabric, and which is the post depositional changes which occur in the Lockhart limestone. So Lockhart limestone, we found the microtization, we find the new morphism, which is change of the mineral from aragonite to calcite, which is compaction due to compression. We found the compaction due to the compaction. We found the microfracture in which later on filled by the calcite. We found the stylolite. We found the dolomitization of various dolomitization, and also dissolution is also present in our thin section. It's known as the post-depositional diagenetic fabric, which is important for the porosity. Some diagenetic fabric increase the porosity, some decrease the porosity, which is mostly the oil and gas industry focus on this diagenetic fabric. So it also gives the history of diagenetics. So firstly, microtizations occur at marine temperature, and then we have found the new morphism, and then compaction, fracture, and cementation later on due to the burial of the Lockhart limestone. So conclusion is this: Lockhart limestone is a nodular interpreted limestone, and 9 species suggested, which shows the inner to middle ramp. It is dominated by this fossil, which give this age, and same as this Zangbu formation, the Tibet is also like the Lockhart limestone, and also assigned this Tenetian age due to the diagenetic fabric, marine meteoric and burial diagenesis, also a potential for the hydrocarbon analysis. So today, my present master thesis on the Cretaceous ocean chemistry, how they are linked to the Paleocene carbonate. So they are linked because of the same Tethys ocean are which I studied in the Paleocene. So I study in the Cretaceous. So it will be give me a good chemistry or good study of the Tethys ocean from Cretaceous to Paleocene. But in this Cretaceous, I will be used my by the undergraduate knowledge of the thin section sedimentology plus the biomarker analysis. So this is our the study area which I propose, and I will be study on the Cretaceous strata, and this is basically the field picture of the Cretaceous strata, which you can see the anoxic boundary, pelagic limestone interpreted with shell. This is the also anoxic boundary cinnamon body OA2, which is located in the Mughal court section. We can see it. This is the area, this red area, and this is the last field picture of the Cretaceous strata interpreted limestone, which we have the different OAE oxygen anoxic boundaries located. So this is the basically reference of the different papers which I studied and studied by Paleocene and Cretaceous strata, especially the paleo environment analysis. Thank you so much for joining us, and hope you will be gain some knowledge.